Hello. So this week we're going to talk about compound events in probability. So the first concept that we're going to go over is one called a tree. How do you make a tree diagram? So that this will help you throughout your probability events when you have compound events. So as an example, number one, it says a marathon has three scattered starting times, each called a wave. So you can see here, there are three waves, A, B, and C. Each wave has five starting areas, that are called corrals. So there's five corrals. The runners are grouped into. So that means that in a race there are different starting times, and these are called waves. So whoever starts at this time or next time or the next time, they're put into five corrals depending how fast you are as a runner. Those are called corrals. Um so that's how they do most races. So we're going to draw a tree diagram that shows the possible waves and corrals a runner could be assigned to. This is how we do it. So we have A, B, and C. And then there's um, three possible waves. Within those waves, each has five possible corrals. So one, two, three, four, five. One, two, three, four, five. And one, two, three, four, five. And then you can do this is why it's called a tree, because it looks like a little tree with the branches. Okay. All right. So that is called a tree diagram. So the first question says, how many different wave and choral assignments are there? So how many are here? One, two, three, four, five. Five times three times, so that's 15, right? If waves and chorals are randomly assigned, find the probability that is wave B, choral 5. So there are 3 times 5, 15. So that's 15. And there's one possibility that it's 1 over 15. So B. So B, wave B, choral 5. Okay. All right. So then it says compound events. The probability of two or more simple events. Okay. So two or more simple events it can be independent events or dependent events. We're going to look at independent events first. In independent events, the outcome of one event does not affect the outcome of the other event. So they're totally independent from each other. And how do we do that? Let's work on multiplication. Then it says the probability of two independent events is found by multiplying the probability of the first event by the probability of the second event. So they don't have to do with each other. It's just that was my dog sneezing. It's just they don't have any they don't affect each other. So they have nothing to do with each other. So you multiply. Now we're gonna remember the concept of multiplication of fractions. So what is the probability of rolling a standard die twice and getting an even number than 5? So the probability of rolling a standard die twice would be, you have two possible scenarios, right? Because there are six numbers, right? That's twice. Now, the getting an even number between 1 to 6, there are three numbers that are even, and then getting a 5, it's one. There's 1 5 in that when throwing a die, and then you just multiply top numbers and then bottom numbers and then simplify. 1 times 3 is 3. 6 times 6 is 36, and then that goes into 3 goes into 36 one time. So 12 times. Sorry, 3 times divided by 3 is 12, and that is your answer right here. Okay, so then I'm gonna do the ones in circled. So the next one, it says, what is the probability of tossing a coin 3 times and getting tails each time? So you toss a coin 3 times, right? 3 times. And then the probability of each being a tails, it's 1/2. So one possible favorable outcome. And that's it. So that you multiply each other top numbers and then bottom numbers. That's 1, and then 2 times 2 is 4, times 2 is 8. Whenever you have a 1 on the numerator, it's already simplified, okay? All right, so I'm gonna do this one, A, and then you guys finish it. So if each spinner to the left is spun once, find each probability. So I'm gonna do this one. So it says the probability that falls on an 11, then red. So then it falls on an 11, so that's 1 over, how many are there? 12 times, then red. Here, this is the first one, and this is the second one, right? So then that falls on red, 1 and 2. 2 over 5, right? 2, there's 2 reds over 5 in total. So that's 1 times 2 is 2, and 12 times 5 is 60. And then that goes into 2 twice. Okay, and that is my answer. All right, so then so look at which one goes first, then the other one. So you just multiply. All right, so I'm gonna do the one with the cards. So remember there are 52 cards in total, right? And that's standard deck. Then it says a card is randomly drawn from a standard deck. Then a date in the month of June is chosen at random. There are in June has 30 days, right? Okay, so it says the probability that you get an ace. There are 4 A's, and then aces in a deck of cards, and then that you get an odd number between 1 and 30, right? Days, right? All right. So there are 15 days that are odd and 15 days that are even in the month of June. So the probability that you get an ace out of 52 is 4 times because there are 4 suits. So 52, and then times that you get 15, that you get odd numbers in the month of June, it's going to be half of the days, which is 15 over the total days. Then you multiply across and you get 60 over 1,560, and then you divide that. 60 goes into 15 1560 60 times. Okay, so then that's the answer right here. Notice that once I get a 1, it's simplified. Okay, let's move on. This example, we're gonna use this spinner here. We have to here remember what is a quadrilateral and what is a parallelogram, because I hope you know what a triangle is and a square. Okay, so it says the spinner to the left is spun once, then a standard die is rolled. So two things are happening. That this is spinning, and then a standard die, like a 1 to 6 die, is spun. So find the probability of each situation here. So it says the probability that it falls on a quadrilateral, then you get a 6 in the die. All right, so we know that. Let's see a quadrilateral. So let's see how many are quad. I wrote it here for you. Quadrilateral is 1. We have 2, 3, 4, 5, 6. There are 6 quadrilaterals. So 6 quadrilaterals, and there's a total of 8 times, and then that you fall that you spin, you roll, you toss a die, you roll a die, and then you get a 6. So there's 1 6 in those numbers. So then you multiply that 6 over 48. 6 goes into 48. So we divide 1 over 8. That's your answer. Okay. Okay, one more here. So then you read, this goes with A, B, and C, D. Here, remember to find a total here. Find a total. Okay, so the next concept we're going to go over is dependent events. So the difference between these events is that they affect. So what one happening affects the other one happening. So in dependent events, the outcome of one event affects the outcome of the other event. So the probability of two dependent events is found by multiplying the probability of the first event by the probability of the second event after the first event has already occurred. So you got to make some changes there. So in example 7, there are 3 green markers, 6 yellow markers, 4 red markers, and 12 blue markers in a pencil box. A marker is drawn, not replaced. So that is your cue right there. It's not being replaced. So you're not putting back the marker in the box. Then another marker is drawn, find its probability. So first we count how many we have in total. We have, I think there was 25. Yeah, so 25. We have 25 in total. That's our denominator. Then it says, it's not replaced. So the first one that we're looking for, it's red. So how many reds are there? Markers, green, red. There are 4 reds. And then the next one would be that then it's not replaced. Since we have that marker out, this drops the number by 1, right? So it's 24. But then what are they asking? Then the thing is blue. So 12. 12 are blue. And that is my answer. Now remember, in dependent events, you're counting one less here. So because you're taking it out and not replacing it. So your count drops by 1. And that's the idea of that's the main concept of the dependent events. All right, now you will multiply across and we get 48 over 600. And then you simplify that and you get 2 over 25. Okay, so find a number that divides both. That's how you simplify. All right, let's do this one. So then what happens when both are blue? So you're not replacing. There are 2 events happening. So you take one first. That counts it down by 1. But if it's blue, you count down by 1 too. So how many blues are there? There are 12. So in the first drawn, you have 12 over 25. But in the second one, it drops by 1, the total. But the blues, because it's blue, it also drops by 1. And then you multiply. 2 events happening. So you get 132 over 600. You divide that, and then you get 11 over 50, which is a simplification. How do I get that? You divide the numbers by the same number to get that. Okay. All right. So I hope this helps. If you guys don't simplify, that's fine, like something like this, but I expect you to simplify most of them. So like in this case, this is very simple to simplify. Okay. All right. Any questions? Let me know. Remember, you have your classes showing up on Tuesdays at 11 a.m. Have a nice day, everyone.